Morning, all of you. Welcome to Sri Jayendra Trank Zone. Today we are going to discuss new lesson. It is new concept in surface chemistry. In the previous session, we have completed preparation of colloids, properties of colloids, and purification of colloids. Now we are going to discuss more about colloids. This colloids is very important concept. Definitely, you are going to get one question for board exams. Sorry, for objective exams, for all competitive exams. So please listen to the class carefully and try to understand it. It is very easy. Now, next topic in this chapter is charge on colloidal particles. Charge on colloidal particles. So what is the charge on colloidal particles? So already we know the size of colloidal particles. Now we are going to look after the charge on colloidal particles. The charge on the colloidal particles is due to the preferential adsorption of a component ion from the dispersion medium. So what is this preferential adsorption? We are going to discuss now. So the charge on the colloidal particles is due to the preferential adsorption preferential adsorption of a component ion from the dispersion medium. The salt may be positively charged or negatively charged. Very important. They'll ask about the charges of salts in the examination also. Metallic hydroxide salts are generally positively charged, like ferric hydroxide and so on. So, due to adsorption of metal ions, that is ion ions in ferric hydroxide. Example is ferric hydroxide. So, metallic hydroxide, not only ferric hydroxide, all metallic hydroxide salts are generally positively charged due to the adsorption of metal ions. This point is very important. Metal sulfide salts like arsenic sulfide, antimony sulfide, etc. Arsenic sulfide, antimony sulfide, etc. Metal sulfide salts are generally negatively charged due to adsorption of sulfur ions from the medium, due to adsorption of non-metal ions, that is sulfur ions. As the charge of sulfur ions is negative, so they are negatively charged salts. As a charge of metal is positive, so they are called positively charged salts. So metallic hydroxide salts are generally positive, and metal sulfide salts are generally negative charge due to adsorption of sulfur ions from the medium. So I hope it is clear. So the charge on the colloidal particles may be positive or negatively charged. Silver iodide salt, that is AgI. Silver iodide, that is AgI. Salts can have either positive charge or negative charge. This is important. When it is having positive charge, when it is having negative charge, we are going to discuss now. Due to the adsorption of either silver ions, if it absorbs silver ions, it is positive. And if it absorbs iodide ions, it is negative. So positive and negative from the medium. So silver iodide, iodine ions are silver iodide Ag plus. AgNO3 to excess potassium iodide is negative colloid. When you add silver nitrate to excess of potassium iodide, due to the formation of due to the absorption of nitrate ion or iodide ion, it is a negative colloid finally. And when potassium iodide is added to silver nitrate, excess of silver nitrate, it becomes positive colloid due to the adsorption of potassium ions or silver ions, because potassium is positive and silver is positive. So silver iodide salt can have either positive charge or negative charge due to the adsorption of either silver ions or iodide ions from the medium. So for silver iodine, it is negative. Silver iodide, Ag plus adsorption, it is positive. Silver nitrate to excess potassium iodide is negative colloid, and potassium iodide to excess silver nitrate is positive colloid. So all these points are important for objective point of view. Anything they can ask in the objective exams. So that's why you have to be thorough with all the concept. Now, what is zeta potential? The charged colloidal particles attract the oppositely charged ions from the dispersion medium. As the colloidal particles are charged, just now we discussed, either they have positive charge or they have negative charge. So they attract the oppositely charged ions from the dispersion medium. An electric double layer is formed on the surface of colloidal particle. This is a colloidal particle, positive colloidal particle, and fixed layer. Then an electrical double layer is formed on the surface of the colloidal particle, that is Helmholtz electrical double layer. It is called double layer. This is the double layer we have seen. The difference in potential between these two layers, the difference between the potential between these two layers is known as zeta potential or electrokinetic potential. Zeta potential or electrokinetic potential. So this is called zeta potential. So as the colloidal particles are charged, they attract the oppositely charged ions from the dispersion medium. So they form a double layer, and in that double layer is nothing but what? Zeta potential or electrokinetic potential. I hope it is clear. Next, stability of lyophobic salts. Now, we have seen lyophobic salts and lyophilic salts. The stability of lyophobic salts is only due to charge on it. Due to the presence of like charges, the colloidal particles repel each other and cannot form aggregates. That's why these lyophobic salts are unstable. As they cannot form aggregates, these lyophobic salts are unstable because they cannot form aggregates because of the like charge. Due to the presence of like charges, the colloidal particles repel each other and cannot form aggregates. The particle size will be in colloidal range only, and hence they are stable. As the particle size will be in colloidal range, but they are stable. But usually they are unstable. They are less stable than lyophilic salts. I hope it is clear. Examples of positive and negative charge salts. Positively charged. This table is very, very important. Which of the following is positively charged salt? Which of the following is negatively charged salt? They'll ask in the examination. Positively charged salts. Hydrated metallic oxides are positively charged salts. Example, aluminum oxide dot XH2O, chromium oxide dot X molecules of water, and ferric oxide dot X molecules of water. Basic dyestuffs. Example, methylene blue solution is a positively charged salt. Hemoglobin, our blood, human blood is a positively charged salt, and oxides of titanium dioxide salts are also positively charged salts. So these are the examples of positively charged salts. All these examples are important because they're asking the examination. Basic dye stuff is an example of positively charged salt. The charge on the basic dye stuff is positively charged. The charge on hemoglobin is positively charged. The charge on titanium dioxide is positively charged salt. So like that we have negatively charged salts, metal salts. You can see here generally metal salts means you will think it is positive, but here it is negatively charged salt due to the formation of zeta potential. Copper, silver, gold salts examples are negatively charged salts. Individual metallic salts are negatively charged salts. Metallic sulfates, as we already discussed, metallic sulfates like arsenic sulfate, antimony sulfide, cadmium sulfate salts are usually negatively charged because due to the adsorption of sulfide ions on them, due to adsorption of sulfide ions, the metallic salts are negatively charged. Metallic sulfide salts are negatively charged. Acidic dyestuffs. Example, congoid salts. Acidic dyestuffs are also negatively charged salts. Basic dyestuffs are positively charged salts, and acidic dyestuffs are negatively charged salts. And salts of starch, gum, gelatin, clay, charcoal, etc. are also negatively charged salts. Salts of starch, gum, gelatin, clay, charcoal, etc. All of these are negatively charged salts. So they'll ask question based on this table. Which of the following is a positively charged salt? Which of the following is a negatively charged salt? They'll give options. So in that options you have to identify. If the options are nothing but metallic oxide, hydrated metallic oxides, blindly you can say it is positively charged salt. Basic dye stuff like methylene blue solution, it is a positively charged salt. Hemoglobin, positively charged. Oxides of titanium, also positively charged salts. Metallic sulfides, metals, acidic dyestuffs, starch, gum, gelatin, clay, charcoal, etc. These are all called negatively charged salts. I hope it is clear. Next, very important concept, electrophoresis. What is an electrophoresis? Electrophoresis is the movement of colloidal particles under the influence of electric field. If you apply electric, as the colloidal particles are charged, when you apply external EMF, that is current, or when you connected it to a battery, automatically the movement of colloidal particles takes place under the influence of this electric field. So which is commonly called as electrophoresis. I hope it is clear. So what is electrophoresis? Since colloidal particles, here I'm writing here, since colloidal particles or colloidal salts are charged, colloidal particles are charged under the influence of electric field. Under the influence of electric field, the movement of colloidal particles takes place. This is called as the movement of colloidal particles under the influence of an electric field is called as electrophoresis. This is used to identify the charge on the colloidal particles. If the movement of colloidal particles is towards cathode, very important, it is towards cathode, it is known as cataphoresis. If the movement of colloidal particles is towards anode, it is known as anophoresis. So automatically, unlike charges attract each other, so when you under the influence of electric field, these colloidal particles will either move towards cathode or anode in the container. If they are moving, if the movement of colloidal particles is towards cathode, it is called cataphoresis. And if the movement of colloidal particles is towards anode, it is known as anophoresis. So I hope it is clear. So this is called electrophoresis. Electrophoresis is nothing but movement of colloidal particles under the influence of electric field. A U-shaped container is filled with colloidal solution should be taken. Electrodes are dipped in two limbs of the U-tube on passing electricity by the means of the electrodes, because these electrodes are connected to the battery. So positive electrode is anode, negative electrode is cathode, means nothing but negative cathode is connected to the negative terminal and anode is connected to the positive terminal. On passing electricity, the colloidal particles move towards opposite electrodes because of unlike charges attract each other. So there is a decrease in the level of the salt in one of the limbs. So which is nothing but what? Electrophoresis. You can see the diagram here. So anode is negative electrode, cathode is positive electrode, but they are connected to, anode is connected to positive terminal of the battery and cathode is connected to negative terminal of the battery. As if the colloidal solution is positively charged, if the colloidal solution is positively charged, then the colloidal particles will move towards anode. If the colloidal solution is negatively charged, then the colloidal particles will move towards cathode. For example, here I'll write simple example. If we take metallic salts under electrophoresis, metallic salts, as metallic salts are negative, as metallic salts are negatively charged, they move towards they move towards anode. Very important, they move towards anode in an electric field, under the influence of electric field, under the influence of electric field. Similarly, if we take metallic hydroxide salts, sorry, this is they move towards cathode. I am very sorry here. We are right. They move because they are negative charge, so they move towards cathode. And metallic hydroxide salts are positively charged, salts. Hence, they move towards anode. They move towards anode. These two statements is clear under the influence of electric field. So by the means of passing current, they move towards anode. You can see the level of raising the solution particles in either anode side or cathode side. So this is called electrophoresis. I hope it is clear. So electrophoresis is nothing but the movement of colloidal particles under the influence of an electric field. So if the colloidal particles are positively charged salts, they move towards anode. And if the colloidal particles are negatively charged salts, they move towards cathode in an electric field. So this is called, and hence it is called cataphoresis, and here it is called anaphoresis. I hope it is clear. So they'll ask each and every point in the examination. Even from the experiment also they can ask the questions. So that's why it is very important to know the experimental data. What is electroosmosis? If the movement of colloidal particles towards oppositely charged electrodes is stopped by the means of semi-permeable membrane, so we can stop this movement of colloidal particles towards oppositely charged electrodes by the means of SPM, semi-permeable membrane or parchment paper. Then the molecules of dispersion medium will move to the semi-permeable membrane. Means here the molecules, the water molecules or whatever, the molecules of the dispersion medium will move by the means of this SPM under the applied electric field in a direction opposite to that of colloidal particles. So this phenomenon is known as electroosmosis. Very, very important. What is electroosmosis? If the movement of colloidal particles towards oppositely charged electrodes is stopped by the means of a SPM, that is semi-permeable membrane, then the molecules of the dispersion medium will move to the semi-permeable membrane, and this movement under the applied electric field and this dispersion medium molecules, that is larger molecules, will go in a direction opposite to that of colloidal particles. This phenomenon is known as electroosmosis. So if anaphoresis takes place, the dispersion medium particles goes towards cathode. If cataphoresis takes place, the dispersion medium particles will move towards anode. I hope it is clear. So if the movement of colloidal particles towards oppositely charged electrodes is stopped by the means of semi-permeable membrane, means by introducing semi-SPM in the electrophoresis experiment, then the molecules of the dispersion medium, that is the larger molecules, will move to the semi-permeable membrane under the application of electric field in a direction opposite to that of colloidal particles. So underline statement is very, very important. Please note it down in your classwork. This phenomenon is known as electroosmosis. So electroosmosis is nothing but just like osmosis. That is nothing but the flowing of solvent molecules by the means of SPM, semi permeable membrane from high concentration to low concentration. That is called general osmosis. The same way here, this is called electroosmosis. I hope it is clear. It is easy to understand. So please note down what are the underlined points I have done here. Next, coagulation, very, very important. From this, definitely you'll get a question. What is coagulation or flocculation? Coagulation is also known as flocculation. Flocculation, the process of converting particles of colloidal size into particles of suspension size. Colloidal size particles can convert into normal size, that is suspension size. It is known as flocculation. Means nothing but simply we are converting the colloidal solution into a precipitate. In simple words, we can convert the colloidal solution into a suspension. Means what? It is a precipitate, into a precipitate. If you want to convert a colloidal solution to precipitate, it is nothing but the process of converting colloidal solution into a precipitate is called as coagulation or flocculation. Coagulation or flocculation can be brought about by electrophoresis, mixing of oppositely charged salts, boiling, and adding suitable electrolytes. All these 4 points are important. We can do coagulation by using electrophoresis, mixing of oppositely charged salts, boiling, or by adding suitable electrolytes. So what is electrophoresis? Already we have done. So to coagulate a positively charged salt, we have to use a negatively charged salt. That is mixing of oppositely charged salt. And to coagulate a positively charged salt or any colloidal particle, we can do it by boiling, and also we can add by suitable electrolytes. So any of these 4 methods is important. So coagulation can be brought. So what is coagulation in simple matter? It is nothing but converting particles of colloidal size into particles of suspension size. The process of converting particles of colloidal size into particles of suspension size is known as coagulation or flocculation. So it is, in simple words, is nothing but conversion of a colloidal solution into a precipitate. Suspension means what? Precipitate. That is nothing but insoluble substance. I hope it is clear. So this is called coagulation. It can be done by 4 methods. Electrophoresis, that is nothing but by introducing a SPM, that is semi-permeable membrane, that is to electroosmosis, that is SPM. Next, by mixing oppositely charged salts. For positive, we have to use negative. For negative, we have to use positive. Next, by boiling. Next, by adding suitable electrolytes. So, by any of these methods, we can do coagulation for a colloidal solution. What is coagulation? Basically, the conversion of a colloidal solution into a precipitate, that is insoluble substance. That is why it is called suspension. Next, how to do by electrophoresis. During electrophoresis, the colloidal particles move towards oppositely charged particles, that is oppositely charged electrodes, and near the electrodes they get discharged. Once they get discharged, they form aggregates and precipitate. So, if you don't introduce any semi-permeable membrane, automatically during electrophoresis, for example, if you are taking ferric hydroxide electrophoresis, then what happens? It is a positively charged salt. So, as the colloidal particles by the means of electric field, what happens? The ferric hydroxide, that is ferric hydroxide colloidal particles, the ferric hydroxide, for example, I'm telling ferric hydroxide colloidal particles move towards anode. Colloidal particles, what? Colloidal solution move towards anode. As they are moving towards anode, once they go to anode, they get neutral because they get discharged, because these are positively charged salts and anode is negative. So they get discharged. Once they get discharged, they form aggregates and precipitate. They form aggregates and precipitate themselves. This is called as coagulation by the means of electrophoresis. Coagulation by the means of electrophoresis. I hope it is clear. Next, by mixing of two oppositely charged salts. So when oppositely charged salts are mixed, their charges get neutralized. Once the charge on colloidal particles is removed, they aggregates and precipitate down. This is known as mutual coagulation. So to coagulate a positively charged salt, we have to use negatively charged salt. And to coagulate a negative charged salt, we have to use positively charged salt. So once the charge on the colloidal particles is removed, they become aggregate and precipitate down. So only our motto is to make the colloidal solution neutralize. If you make the colloidal solution neutralize, they become precipitate. That is nothing but what? Coagulation. This is also known as mutual coagulation. Next, by boiling. When a salt is boiled, the adsorbed layer of ions, the adsorbed layer of ions is disturbed. Sorry, the adsorbed layer of ions is disturbed due to molecular collisions. This charge is decreased and the salt coagulates to form a precipitate. So what is the motto of coagulation? Nothing but to become a precipitate. That is, colloidal particles become suspension particles. So that is called coagulation. So by boiling also we can do precipitation by, because when the salt is boiled, what happens? The adsorbed layer of ions is disturbed due to molecular collisions, due to which what happens? It loses its charge by becoming neutral. I hope it is clear. Next. Next, persistent dialysis. Persistent dialysis. So what is this persistent dialysis? We'll discuss now. When the dialysis is carried out for a long time, all the ions are removed from the solution. This will make colloidal particles unstable since there is no absorption of ions on its surface. The particles aggregate and settle down. So that's what I told you. Purification of blood can be done by using dialysis. When the dialysis is carried out for a long time, all the ions are removed from the solution. This will make colloidal particles unstable since there is no adsorption of ions on its surface. As they are removing all the ions, the particles aggregates and settle down and becomes precipitate. So this is called persistent dialysis. Next, by adding electrolytes, this is very important. So by adding electrolyte, which electrolyte should be added, we have to note it down. So by adding electrolytes, by the addition of suitable electrolytes, the charge on the colloidal particles is neutralized. The colloidal particles forms aggregates and precipitate down. A negative ion can coagulate a positively charged salt, and a positive ion can coagulate a negatively charged salt. For example, to coagulate ferric hydroxide, to coagulate, I'm writing here, to coagulate ferric hydroxide salt, since it is positively charged, sulfide ions are used. Nothing but what here? A negative ion can coagulate a positive salt and positive salt, and a positive ion coagulates a negative salt. For metallic salts, since they are metallic salts are negatively. For metallic salts, it can be coagulated by using metallic ions. It can coagulate it can coagulate by using metal ions. So a negative ion can coagulate a positive salt, and a positive ion can coagulate a negative salt. So this is called by adding electrolytes. By adding electrolytes, I hope it is clear. So this is nothing but coagulation. All the four methods. Next, very important. From this also they'll ask question: what is Hardy-School's rule? What is Hardy-School's rule? Let us discuss now. The ion which is responsible for coagulation is known as active ion or coagulating ion. Higher the charge on the active ion, this statement based question they will ask in the examination. Higher the charge on an active ion, higher will be its power of coagulation. That is, higher will be its coagulating power. For negatively solved, the order of coagulating power of positive ion C is, which can coagulate more easily. The ion with higher charge, the higher the charge on the active ion. For example, aluminum, what is the charge? +3, barium +2, sodium plus. So the order of coagulation will be aluminum is having greater coagulating power than barium than sodium. So to coagulate a negatively charged salt, we have to use coagulating power on the positive charge, positive ions. So the positive ion can be in the order higher the charge on the active ion, higher will be its coagulating power. So which can coagulate more easily between aluminum, barium, and sodium? Aluminum, because the charge on aluminum is +3. Very important. From this, they have asked many questions. So from this concept only, they asked many questions in competitive exams. So for positively charged salt, the order of coagulating power of anions also higher the power on the active ion, more the anion charge, negative charge, more is the coagulating power, more the positive charge, more is the coagulating power. So in general, to coagulate a negatively charged salt, the order of coagulating power of positive ions is higher the charge, L+3 greater than Ba+2 greater than Na plus. And to coagulate a positive salt, the order of coagulating power of anions will be cyanide ions, that is ferric cyanide ions, 4 minus, phosphate ions, 3 minus, sulfate ions, 2 minus, and chlorine minus ions, 1 minus. So higher the charge, either positive or negative, higher is the coagulating power. Very important. From these two lines, they'll ask one question definitely that we are going to discuss at the end of the class. I hope it is clear. So this is called Hardy-School's rule. According to Hardy-School's rule, higher the charge on the active ion, higher will be its coagulating power. I hope it is clear. Very important. Please note it down in your classwork. Definitely, you are getting benefited by this PPT. They are going to ask one question for either Neet or JE means. Coagulation of lyophilic salts. Lyophilic salts are stable due to, actually, these should be lyophobic salts. It should be lyophobic because lyophobic salts are less basic. Coagulation of lyophobic salts. Lyophilic salts are stable due to higher degree of solvation charge on the colloidal particles. Lyophilic salts are coagulated by adding an electrolyte and by adding a suitable solvent. When alcohol or acetone is added to a salt, dehydration of dispersed medium occurs. So adding a small amount of electrolyte will coagulate the salt. So we can coagulate the lyophilic salt as well as lyophobic salt. To coagulate, for coagulation, what you have to do? Lyophilic salts are coagulated by adding an electrolyte. What is lyophilic salts means? They are nothing but solvent loving, and lyophobic means solvent hating. So lyophilic salts are coagulated by adding an electrolyte and by adding a suitable solvent. When alcohol or acetone is added to a salt, dehydration of dispersed medium takes place. Adding a small amount of electrolyte will coagulate the salt. I hope it is clear. So all these points are most important because you are going to definitely you are going to get questions from this. Next, protective colloids. What are protective colloids? A protective colloid is a lyophilic colloid which is added to the lyophobic colloid to increase its stability. As lyophobic colloids are less stable than lyophilic colloid, if you add a lyophilic colloid as a protective layer, a protective colloid is a lyophilic colloid which is added to the lyophobic colloid to increase its stability. The lyophilic colloid forms a protective layer over the surface of lyophobic colloid and prevents coagulation. To prevent coagulation, we can add a lyophilic colloid on the surface of lyophobic colloid so that it forms a protective layer. Hence, it prevents coagulation. Next, emulsions. Last topic in this chapter is emulsions. What are emulsions we are going to discuss now? So what are emulsions and what is the use of emulsions we are going to discuss now. Emulsion is a colloidal solution in which liquid is dispersed in another liquid. So what is the type of emulsions means? Liquid, dispersed phase is liquid and dispersion medium is also liquid. Dispersed phase in liquid and dispersion medium is also liquid. Liquid type. Liquid type is called emulsion. So liquid, dispersion medium as well as dispersed phase. Dispersed phase is liquid. Dispersed phase is liquid as well as dispersion medium also. Dispersion medium also liquid. Liquid type solve. It is nothing but what? Emulsions. So two types of emulsions may be formed. That is, one is oil in water type and water in oil type. They'll ask these types of emulsions also. Oil in water type. There are two types of emulsions. Oil in water. So oil in water, oil droplets are present in water, and water in oil. In oil, water droplets are present. So this is nothing but oil in water, water in oil drop. So I hope it is clear. Now we will discuss more about emulsions now. Let us see. Oil in water type. First type. The dispersed phase is oil and the dispersion medium is water. So oil in water means what? Water is the dispersed phase and oil is dispersed medium. Sorry, water is the dispersion medium and oil is the dispersed phase. Example, milk. They'll ask milk is an emulsion, which is nothing but what type? Oil in water or water in oil type. They'll ask the question like this. The dispersed phase is oil and the dispersion medium is water. Milk, fat dispersed in water, vanishing cream, etc. All these are examples of emulsions, that is oil in water type. The dispersed phase is water and the dispersion medium is oil. Oil is more in quantity and water is less in quantity. Example, butter, cod liver oil. It is used for fish. Actually, this cod liver oil is taken from fish. Actually, it is used for asthma, treating asthma. Butter, cod liver oil, cold cream, etc. This cod liver oil capsules. These cod liver oil capsules. It is made from fish. It is made from fishes. Which is used for breathing. Means, for example, to cure asthma or breathing problems. It is used to cure breathing problems in our body. So I hope it is clear. Breathing problems. Next. So the dispersed phase is water and the dispersion medium is oil. This is called water and oil type. Example, butter, cod liver oil, cold cream, etc. Next, what is an emulsifying agents? These are the substances added to emulsions in order to stabilize the emulsion. To stabilize the emulsion, we are using emulsifying agents. These are the substances added to emulsions in order to stabilize the emulsion. Emulsifying agents or emulsifiers form an interfacial film between the particles and the medium. Example, proteins, gums, natural and synthetic soaps, etc. These are nothing but emulsifiers or emulsifying agents. So what is the emulsifying agent? Our emulsifiers will do, it forms an interfacial film between the particles of the and the medium, due to which what happens? These are added to emulsions in order to stabilize the emulsion. Stabilize the emulsion means it should be stabilize the emulsion. I hope it is clear. Next, examples of colloidal. Examples of colloids in nature. Colloids in nature. So what are the examples of colloids in nature? We have, let us discuss now. Blue color of sky, mist, fog and rain, blood, food items, formation of delta lesion. These are all the natural colloids. Natural colloids. So blue color of sky is due to the scattering of light by the dust particles present in the atmosphere. That is nothing but what? Tyndall effect. In natural, we can say it is nothing but scattering of light particles. That is nothing but what? Tyndall effect. So when light particles, when sunlight is incident on the dust particles in the air, what happens? The dust particles, that is nothing but the dust particles are colloidal particles. They absorb the light and then these dust particles scatter the light, scatters the scattering of light takes place, due to which what happens? The color of the sky is appear blue due to the scattering of light by the dust particles present in the atmosphere, which is commonly called as Tyndall effect. What is it is called? Tyndall effect. Next, fog, mist, and rain. When air is cooled, the moisture present in air will form droplets which floats in air as mist or fog. This is also nothing but colloidal system. Clouds are colloidal systems containing fine droplets of water. As I told you, cloud is an example of liquid in liquid. Dispersion medium is liquid and dispersion, sorry, liquid in gas. Clouds are nothing but what? Liquid in gas, because the dispersed phase particles are liquids and dispersion medium is air, that is gas. So clouds are colloidal system containing fine droplets of water. So clouds nothing but they form water. Fine droplets of water will be acting as they are nothing but dispersed phase particles. Fine droplets of water are called as dispersed phase particles, and the dispersion medium is air. Dispersed phase particles, and the air is called dispersion medium. When clouds which are oppositely charged come near to each other, they get coagulated and water droplets aggregate and fall in the form of rain. So when clouds which are oppositely charged come near to each other, they get coagulated and water drop means they form precipitate and water droplets aggregate and fall in the form of rain. So this is the natural example of coagulation. Natural example of coagulation. Next, food items. Many of the food items like milk, jam, bread, juice, etc. are colloidal in nature. As I told you, milk is nothing but oil in water type. So milk contains fats. So jam, bread slice, and juice, etc. are colloidal in nature. Next, blood. Blood is a colloidal solution. Human blood is a colloidal solution. When the bleeding takes place, the blood gets clotted. The clotting of blood is coagulation. Very, very important. Whenever you get hurt, the bleeding takes place and the blood gets clotted. The clotting of blood is nothing but coagulation, which prevents the further bleeding. So it has a natural tendency to become coagulation. So blood is a colloidal solution. Next, formation of deltas. So river water contains colloidal particles of clay. Clay means nothing but mud in water. So when river meets sea, these colloidal particles are coagulated by the electrolytes present in seawater, because seawater contains salts. As seawater contains salts, what happens? These clay particles, when this river meets sea, these colloidal particles are coagulated by the electrolytes present in seawater. The region where coagulation takes place will appear like a delta. Delta, I think you know what is delta also. So the region where coagulation takes place will appear like a delta. So this is the natural example of formation of delta by us. That is nothing but when river water, because river water contains colloidal particles of clay. When river water meets sea, these colloidal particles are coagulated by the electrolytes present in the seawater, where it forms a delta, because the region where coagulation takes place will appear like a delta. I hope it is clear. So these are the natural colloids we have in the atmosphere. Next, application of colloids. What are the uses of colloids? Last part in this chapter is nothing but what? Application of colloids. So what is the important application of colloids we are going to discuss now? Purification of drinking water, medicines, quartile precipitator, tanning, rubber industry, and industrial products. So let us see what are the use of these colloids. Industrial smoke contains a lot of carbon-based impurities. Because industrial smoke, since many products have been manufactured in the industries, so lot of smoke will be coming out of industries. So the industrial smoke contains a lot of carbon-based impurities. The industrial chimney has quartile precipitator. At the top of the chimney, two electrodes are maintained at high potential difference. When the smoke passes through these, the colloidal particles of carbon are attracted towards the oppositely charged electrodes and get precipitated. So carbon dust-free smoke is let out to atmosphere. So for example, every industry should have this quartile precipitator. If by the means the name itself quartile precipitator means carbon-based impurities get precipitated by using of this. So what is quartile precipitator? It precipitates the industrial smoke. Industrial smoke contains a lot of carbon-based impurities. The industrial chimney has quartile precipitator. At the top of the chimney, the two electrodes are maintained just like electrophoresis. What these two electrodes are maintained at high potential difference, due to which what happens when the smoke passes through these, the colloidal particles become neutral of the carbon are attracted towards the oppositely charged electrodes and get precipitated. This is nothing but what? Electrophoresis. By the means of electrophoresis, these carbon-based impurities gets coagulated in the from the industrial smoke, due to which what happens, carbon dust free smoke is let out to atmosphere because the carbon based impurities will get converted into precipitation. I hope it is clear. So this is called quartile precipitator. Quartile precipitator. I hope it is clear. Next. So this is the example of diagram of quartile precipitator. The carbon dust particles will get precipitated like this. Smoke will be ejected from this, and here this high voltage wire, because it contains cathode and anode. Under the electric field, what happens? The dust-free gases will come out of the chimney, and whatever the dust particles present in the smoke will get settled down as a precipitate. So this is called quartile precipitate, and this process is called as electrophoresis. I hope it is clear. Next, purification of drinking water. How a drinking water is purified. So let us see purification of drinking water. Water contains colloidal impurities. Potash alum is added to water to remove colloidal particles by coagulation. This potash alum is very, very important. It is nothing but double salt containing potassium sulfate, aluminum sulfate, or hydrated potassium sulfate, and also aluminum sulfate. It is a double salt, potash alum. Formula is K2SO4 dot Al2SO4 dot taken twice dot 3H2O. So this when this potassium is added to water, what happens? It brings coagulation in water. It brings coagulation in water. Nothing but it removes coagulated particles by coagulation. Only it has a tendency to attract the colloidal particles towards itself, due to which what happens? They become precipitate, and that precipitate is easily filtered off. So this is nothing but purification of drinking water by adding potassium. Even this potassium you can add on the overhead tank of your apartment also. When you add the potassium on the overhead tank of your apartment, what happens? The whatever the water is being containing impurities will get attracted to it. That is nothing but they form precipitates, and those precipitates can be easily filtered off. I hope it is clear. So this is called purification of drinking water by adding potassium. Next, medicines. How these colloidal particles are used in medicines. Most of the medicines are colloidal in nature. Example, so these medicines also they'll ask in examination. Algoil is a silver sol used as an eye lotion. Colloidal gold is used for intramuscular injection. Intramuscular injection. Milk of magnesia, an emulsion, is used for stomach disorders. Alum or FeCl3 is used to stop bleeding in a minor wounds. So all these are nothing but used as medicines. These are colloidal salts. So alcohol is a silver salt, is used as an eye lotion. Colloidal gold is used for intramuscular injection. Milk of magnesia, an emulsion, is used for stomach disorders. Alum or FeCl3 is used to stop bleeding in minor wounds. So in this way, many colloids are used as medicines. Next, tanning. Tanning of leather is due to coagulation. Tanning is a process of hardening the leather. Hardening the leather is nothing but due to coagulation. And this leather is used as sandals, slippers, or you can say leather products like wallets, etc. So, other applications of colloids, photographic plates and films. Photographic plates or films are prepared by coating an emulsion of the light sensitive silver bromide. These points also they'll ask in examination. What is a photographic plate containing? It contains an emulsion. By coating an emulsion of the light sensitive silver bromide in gelatin over glass plates or cellular films. Next, rubber industry. Latex is a colloidal solution of rubber particles which are negatively charged. Rubber is obtained by coagulation of latex. Industrial products, paints, emulsions, inks, synthetic plastics, rubber, graphite lubricants, cement, etc. all are colloidal solutions. Even cement is also a colloidal solution. Cement is also a colloidal solution. I hope it is clear. So these are the main uses of colloidal solutions. Next, let us discuss some questions and then we'll do summary of the chapter. And this chapter is being completed now. So I'll discuss one question now. This is the previous JEE Mains question. So I'm writing the question here on the board. Please note it down. The coagulating power of electrolytes, question number 1. The coagulating, this has come for JEE Mains 2013 question. The coagulating power of electrolytes, the coagulating power of electrolytes having ions Na plus, comma, aluminum plus 3, comma, barium plus 2. For arsenic sulfate sol, arsenic sulfide sol increases in the order. Increases in the order. This is straight JEE Mains question of 2013. You can see in the books also. First option, Al plus 3 less than Ba plus 2 less than Na plus. Second option, Na plus less than Ba plus 2 less than Al plus 3. Next, third option, Ba plus 2 less than Na plus less than Al plus 3. Next, fourth option, Al plus 3 less than Na plus less than Ba plus 2. Since they have asked the increasing order, there is nothing but coagulating power or flocculation power. So the coagulating power for coagulating arsenic sulfate. Arsenic sulfate is a negatively charged salt. So to coagulate arsenic sulfate salt, we have to use positive electrolytes. So the positive charges are positive ions are Al plus, Ba plus 2 and Na plus. And the coagulating power of electrolytes having ions like sodium ions, aluminum ions, and barium ions for arsenic sulfate increases in the order. They are asking increasing order. So the answer will be second option, because sodium is less coagulating power than barium. Barium is having less coagulating power than aluminum. Because higher the charge on the ion, higher the charge on the ion, you can just note it down this statement. Higher is its coagulating power, either positive charge or negative charge. Higher is its coagulating power. This question is very, very important. So remember this statement, very important statement. What is the statement? Higher the charge on the ion, higher is its coagulating power. So the increasing order of coagulating power is Na plus less than Ba plus 2 less than Al plus 3. I hope it is clear. Next question we are going to discuss now from this previous JEE Mains question only I'm writing here. Question number 2. We are discussing only previous JEE Mains questions. I'm writing here, writing previous questions, previous competitive exam questions. Competitive exam questions. So I'll not drop this, only I'll drop. So question number 2. What is the question number 2? Just I'm writing here on the board. Please note it down. Which of the following statements? Which of the following statement is incorrect? Which of the following statement is incorrect regarding physical adsorption? Option 1, it occurs because of van der Waals force. It occurs due to van der Waals forces. Van der Waals forces. Second option, more easily liquefiable gases. More easily liquefiable gases are adsorbed readily. Are absorbed readily. Third statement is straight JEE Mains question. Under high pressure, under high pressure, it results into multimolecular layer. It results into multi-molecular layer on adsorbent surface. On adsorbent surface. Fourth option, enthalpy of adsorption. Enthalpy of adsorption is low and positive. Is low and positive. So here they have given 4 statements. All the 4 statements is important. So which of the following statements is incorrect regarding physical adsorption? It occurs due to van der Waals forces. More easily liquefiable gases are adsorbed readily. Under high pressure, it results into multimolecular layer on adsorbent surface. And enthalpy of adsorption is low and positive. Very, very important is here the answer is incorrect statement is fourth option because all the 3 are correct. Because enthalpy of adsorption always it can be low in physical adsorption, but it should be negative. It is not positive, it should be negative because enthalpy of adsorption is always an exothermic process. It is not endothermic process. I hope it is clear. Next question. Question number 3. Question number 3. So very important point, gold numbers we have not discussed. Gold numbers, I'll discuss this question also. Gold numbers of protective colloids. Gold numbers of protective colloids A, B, C, and D are respectively, this question is also very important, are respectively 0.50, 0.01, 0.10, yes, 0.10 and 0.005. The correct order of protecting power is the correct order of, this question also very important, the correct order of their protective powers are protective powers are first option D is less than A is less than C is less than B. Second option C is less than B is less than D is less than A. Third option A is less than C is less than C is less than B is less than D. Fourth option B is less than D, D is less than A is less than C. Now, so already we know that as lyophobic salts are unstable, we need to add some lyophilic salts as a form protective layer on the lyophobic salt, so that to prevent coagulation, and that is called as gold number. So gold numbers are given for the protective colloids, and these gold numbers is nothing but, so they are nothing but just like gold numbers are given for protective colloids, and here they are given gold numbers of A, B, and C. These are all the four different protective colloids. A, B, and C, and D are four different colloids having gold numbers 0.50, 0.01, 0.10, and 0.005. And the correct order of their protective powers are, they're asking us to write the correct order of protecting powers. So answer is C, means that is third option. A is less than C is less than B is less than D. Here, what is A value? 0.50, 0.01, 0.10, and 0.005. So this is called protect gold numbers order. So here, what is the answer? Lower the value. Here, A value is 0.5 and least is 0.005. So A is less than C, 0.10 least. So lower the gold number value. Lower the gold number value. Just note down this statement, very important. Lower the gold number value, higher is the protective power. Higher is the protective power. Please note it down. Lower the gold number, higher is the protective power. This statement is very, very important. So next time whenever they give increasing order or decreasing order, we can easily write it down. I hope it is clear. Next. Next question. Let us see some questions based on emulsions as well as colloids. Next question, question number 4. These are all previous competitive questions. Which of the following is not an emulsion? Which of the following? Which of the following is not an emulsion? Which of the following is not an emulsion? Option 1, that is A option, butter is an emulsion, since already we know butter, cod liver oil, etc. This is oil in water type. Second one, sorry, water in oil type. Second one, hair cream is also an emulsion. Third one, milk is also an emulsion, oil in water type. And fourth one, cloud. Cloud is not an emulsion. So answer is cloud. Like these questions also they'll ask in the examination. Next question. Let us see the next question. They can ask based on all the topics. So, and today concept I'm discussing now in this lesson session charge. So that's why I'm discussing only this concept. Yes, listen to questions carefully. Colloidal solutions. Colloidal solutions of gold prepared by different methods. Prepared by different methods have different colors because, very important, have different colors. Have different colors. This we have seen already. When it is light color, gold color, yellow color, like that, have different colors because, very important point. Directly I'm writing the answer because it's very lengthy question. So difference in the diameter of colloidal particles, because difference in the diameter of colloidal gold particles. Colloidal gold particles. So these are the examples, very, very important examples. Next question. So like these questions you will be getting in the examination for competitive exams. They can ask. Now we am going to discuss summary of the chapter, because since many questions we have discussed, now we are going to discuss summary of the chapter. First one. First we have done adsorption. In that we have done types of adsorption. Second one, that is physical adsorption, chemical adsorption. Next, adsorption isotherms. Adsorption isotherms. Next, that is differences between adsorptions, different differences between them, differences between physical and chemical adsorption, physical and chemical adsorption. Second topic we have done catalysis. So in catalysis, we have done many types of catalysis, that is homogeneous, heterogeneous, zeolites, enzymes, etc. Third topic we have done colloids. In colloids, very, very bigger topic in this chapter. So colloids we have done preparation, properties, uses, types of colloids, that is lyophobic and lyophilic, and colloidal systems. We have total 8 systems of colloidal systems. Colloidal system, that is solid in solid, liquid in gas, from colloidal system. Next, last topic we have done emulsions. So these are the 4 topics in this chapter. Emulsion is an exam, nothing but it is also a colloid, but it's an addition of colloids. So from this, these are the 4 different concepts we have done from this chapter. From this chapter, definitely you are going to get 2 questions for any competitive exams. Minimum 2 questions they will give. So they can give usually from adsorption, most important 3-star. I'm giving colloids 3-star, and catalysis 2-star, and emulsion 2-star. So work out more questions on colloids as well as adsorption. Colloids as well as adsorption. You work out almost all the questions by seeing this, by listening to these lectures. Easily you can, I think easily you can do all the questions from any objective material, either from JNR material or from any other competitive material. Easily you can do. I hope it is clear. So all these topics are very, very important for our understanding. It's very, very important. So please note it down and do it accordingly. Do it accordingly. So this is a summary of the chapter: adsorption, catalysis, colloids, emulsions. I hope it is clear. So now we are stopping the class. So please follow the guidelines and do this chapter easily. It's very, very easy. I hope it is clear. Thank you all.